Okay, guys, greetings. This is a walkthrough of the Unit 3 practice test. So let's get started on this. Show all the work where applicable, circular final answer. Okay. Completely factor the following expression. So I remember with factoring, first thing I always look for is a common factor. And then I look for trinomials and patterns, things like that. So I look at this, 6, 21. Hey, these are both divisible by some, 3. 3 will go into each of these. So common factor is 3, but I also notice x squared and x. So I can factor a 3x out of each of these. So to factor out a common factor, I put the common factor out here. The common factor is the thing that divides into each. And then I take each of these and I divide it by that common factor. 6 divided by 3 is 2. X squared divided by x is x. Okay? Positive 21 divided by 3 is positive 7. And x divided by x, that's gone. Okay, then I always have to consider, can I factor the factors? Monomials like that, they're always done. And this, as soon as I see something without a power, if I've already factored out your greatest common factor, this is done. So that is done. And there's no work to show for that, so that's it. 6x squared plus 41x minus 30. 6 and 30. 6 and 2 will go into the 40. Does anything go into 41? What goes into 41? 40. I think 41 is prime. It is. Nothing goes into 41. So this is a trinomial. So I've got to do something like the like the two wrongs make a right. I'm going to do that. So I'll drop some parentheses. I'll go 6x and 6x. The first thing goes here and here. Now I know that's wrong because 6 times 6 doesn't make 6. It makes 36. But I'm going to make it right here in a bit. Then I multiply 6 times negative 30. That makes a 180. And actually, you know what? Timeout. That's negative. So that tells me my sign is going to be plus minus. Doesn't matter where I put it right now because everything's the same. I'm looking for factors of 180 that will make 41. Dang it. I'm not sure. 180 divided by 2. 2 and 90. That doesn't work. 180 divided by 3. 3 and 60. That's not going to work. And remember, my target I'm trying to make is 41. 180 divided by 4. 4 and 40. 4 and 45. I didn't even think about that. 45 minus 4. So 180, 4 times 45. That's it. That's really how I test it. I don't write the list down when I do it. I just start typing into a calculator. Divided by 1, divided by 2, divided by 3, divided by 4. There it is. So it's going to be, that's positive. The big number always takes that sign. So positive 45, negative 4. Okay, double check myself. 45 minus 4 makes 41, and 4 times 45. Great. Okay, now I look at making it right because this is wrong and this is wrong. So I make it right. And I say it's wrong because 6 times 6 doesn't make 6x squared. 45 times 4 doesn't make 30. Okay, 6 and 45. I can divide 3 out of that, I think, right? 6 divided by 3 is 2x, and 45 divided by 3 is 15. Okay, 6 and 4, I can divide 2. So I'm looking for things I can divide out of each of them. Oh, and this works because, see, 3 times 2 is 6. I double counted the 6 at first, so now I'm pulling it out. 6 divided by 2 is 3. X, negative 4 divided by 2 is negative 2. Double check myself. 15 times negative 2 is negative 30. Check. 2 times 3 makes 6. Good. I feel pretty good about that. I could multiply it all the way out and check the middle terms, but I'm confident that's right. Negative 36x squared plus 16. If you ever see a negative leading coefficient, number one idea, factor it out. But look and see, is there a common factor besides the negative? 16, I'll do that. What goes into 16? 1 and 16, but 16 doesn't go into 36. 2 and 8, 2 goes 8. Oh, no, 8 doesn't go in there, but 2 does. 4 and 4, 4 goes into both of these, right? Yeah. Negative 36 divided by negative 4 is 9x squared. And positive 16 divided by negative 4 is negative 4. Great. Oh, wait a second. I almost skipped it and went on. This is a difference of two perfect squares. So always consider, can you factor the factors? 9x squared is a perfect square. The square root of 9x squared is 3x. 4 is a perfect square. The square root of 4 is 2. So to factor these, I drop some parentheses. I put a plus and a minus, and I take the square root of this, which is 3x, and I drop it here and here. And then I take the square root of this, which is 2, and I drop it here and here. And that's now done. Okay. Whew, last one. I'm sorry, I'm yawning. That's terrible. Last one. 4x cubed, 20x x. I see x there, so x is a common factor, but I'm looking at numbers. 4 goes into 20. 56. What's 56 divided by 4? 56 divided by 4 is 14. So 4x is a common factor. Okay. 4 divided by 4 is 1. X cubed divided by x is x squared. So I have 1x squared. 20 divided by 4 is 5. X squared divided by x is x. Negative 56 divided by 4 is negative 14, and the x is gone. Okay. I have to consider, can I factor this? So to think about that, I'm just going to act as if I can factor it. If I can't, I'll just scratch it out. X and X, that's a negative 14, so it's going to be a positive and negative. Are there factors of 14 that I can make 5 out of? Well, 14. 1 and 14. Nope. 2 and 7. Oh, yeah, look at that. I could go positive 7 minus 2, and there that is. Okay, so there. You are going to see on the test 3 or 4 factoring problems are going to be there, and I'll make sure there's a variety so that they're look kind of like that. All right, so trinomials, basic trinomials, common factors, and differences of squares. You'll see all the factoring things we looked at. Okay, now simplify these. I think I should have probably put divide because these are dividing. So to divide, I'm going to set up a table. 10x minus 5. So I need a 10x and a minus 5 there. Okay. And then the first term of the dividend drops right here, 10x cubed. Awesome. Now remember, when I do this, excuse me again, the top times the side is going to give me the inside. So 10x times something is going to give me 10x cubed. The reverse of that is 10 divided by 10 is 1. X cubed divided by x is x squared. Double check. X squared times 10x, yeah, that gives me 10x cubed. Check. So this is right. Now I multiply here. Negative 5 times x squared gives me negative 5x squared. Now I need a negative 75x squared, so I need 70 more. 70 minus 5, that gives me 65. Oh, if I make that a negative 75, negative 70 minus 5, it makes me negative 75x squared. Good. So then I can go negative 70 divided by 10, that's negative 7. X squared divided by x, that's x. And then I can multiply and fill in this. Negative times a negative is positive. 7 times 5 is 35x. Now I have 35x. I need 45x. So the difference is 10. So I got to go plus 10x. 35 plus 10 is 45x. Check. That's right. So be double checking yourself along the way. 10x divided by 10x is a positive 1. Cool. 1 times negative 5 is negative 5. I need negative 15. Well, that's 10 more, right? 10 minus, oh, I missed the sign again. Negative 10 minus 5. That's a negative 15. So the answer is up here, and then there's the remainder. So I've got x squared minus 7x plus 1, and then there's plus the remainder is negative 10. All over the divisor is 10x minus 5. You always take that up there and then add the remainder over this. Now, I guess you could do this. If you wanted to go instead of plus the negative 10, you could just go minus 10 over that, and that's the same thing. Neither one's better than the other. Neither one's wrong. Neither one's right. Well, I mean, neither one's wrong. They're both right. Next one. It's another division problem, so I'm going to set up a box. Da-da-da. Box. There. 10x plus 10. Cool. 20x cubed goes right there. 20x cubed. 20 divided by 10 is 2x squared. 2 times 10 is 20. X squared times x. Perfect. Okay. 2x squared times 10. That's 20x squared. I need a negative 50. So this is going to have to be a negative big number. 70. Right? Negative 70 plus 20 is negative 50. Good. But this will be, sorry again, an x squared. Negative 70 divided by 10 is negative 7. X, right? Negative 7 times 10 is negative 70. X times x is x squared. Good, that works. Negative 7 times 10 is negative 70. X just tags along. I need a negative 170x. So I need another negative 100. These are big numbers. Negative 100x. Negative 100 minus 70. Yeah, it adds up to negative 70. So I'm double checking myself every step. Negative 100 divided by 10 is negative 10. X divided by x is gone. Negative 10 times 10 is negative 100, which, check that out. There's no remainder there. None or 0. So my answer is 2x squared minus 7x minus 10. More than that also, 10x plus 10 is a factor of that. One way to determine if something is a factor of something else is to do the division. If you get no remainder, then that divisor is a factor. And that goes right into the next question. Look at 7. Use the remainder theorem to determine whether x plus 6 is a factor of x cubed minus 3x squared minus 63x minus 54. Justify your answer. Well, one way would be to do the division, but I want to show you a different way. Take the divisor, x plus 6, and set it equal to 0. Solve it. Minus 6 minus 6, and I get x equals negative 6. If this x plus 6 is a remainder, then if I put x equals negative 6 into here, I'm going to get nothing remaining. So I'm going to go negative 6 cubed. So x cubed minus 3 times x, which is negative 6 squared. And this would be how I justify the work. Minus 63 times negative 6 minus 54 equals. Okay, so I type that in. Parentheses, make sure you put parentheses when you substitute these things in there. Negative 6 cubed, okay, minus 3 times negative 6 quantity squared. Oh, they're all in the exponent. See what I did? That was ugly. Minus 3 times negative 6 quantity squared. Okay, minus 63 times negative 6. Minus 63 times a negative 6. Minus 54. Minus 54. Okay, minus 54. I'm just double checking. 63 negative 6. Negative 6 squared. There's a negative 3. Everything looks good. Equals 0. So because that equals 0, x plus 6 is a factor. Make sure you answer the question. And the answer would be yes, it is a factor, or no, it is not a factor. And if you just put yes or no, I'm not sure what you're meaning. So it is a factor. It is not a factor. If you put yes, what do you mean? Yes, it's not a factor, or yes, it is a factor. I don't know what you're talking about. Okay. How many zeros does this polynomial have? 6. This is, look at the exponents. 6, 4, 2, nothing. 6 is the highest exponent. Tells me it's sixth degree. Tells me it has 6 zeros. End behavior. End behavior, first thing I look at is the leading coefficient. It's negative. Tells me it's going down to the right. The degree is even, which means they're the same. So it's down to the left. And I don't care whether you describe it or say down right, down left, or draw it. That's fine. For the polynomial graph below, what's the degree? Well, I don't have the equation, but I do see it crosses here, here, and here, which, by the way, those are the zeros. 1, 2, 3, 4, negative 4, 0, and 1, 2, 3, 4, 5 is the other 0. There's 3 zeros. That means it's a third degree. Now, be careful. If it bounces at one of those zeros, you have to treat that like a multiplicity of 2 and add another 0 on here. Okay? Is the leading coefficient negative or positive? Well, look at the right side. This is going down. The right side is going down. That tells me it's a negative leading coefficient. So I'm just going to circle negative. Okay? Maybe you write it. Write negative. I don't know. Do something. Okay. D, write an equation of the polynomial. Well, an equation of the polynomial in factored form, I'm going to have x plus 4, and I'll have x minus 5. But that 0, easiest, I could do x minus 0, but the easiest way is just drop that. That's factored form. Now, to write it in standard form, I need to multiply that out. X times x, that's x squared. X times 4, that's 4x. And that's being multiplied by x minus 5. If I multiply that out, x squared times x, that's x cubed. X squared times a negative 5x squared. 4x times x, positive 4x squared. 4x times a negative 5 is a negative 20x. So my answer is x cubed minus 5x squared plus 4. Where's the 4x squared? 4x x cubed. 4x times x. X squared times is negative 5x squared. 4x times x is 4x squared. Oh, I don't know why I didn't even notice that. Those are like terms, aren't they? Yeah. What's negative 5 plus 4? Negative 1x squared. And then minus 20x. So multiply it out, distribute, and collect all the like terms. Next problem. Okay, answer this question. What's the degree? Well, in factored form like that, to get the degree, I add the exponents of x. 2 plus 5 is 2 plus 3 is 5, plus 2 more is 7. End behavior. The leading coefficients right here, it's positive. That tells me the left end's going up. And it's an odd degree. That tells me the right end's doing the opposite thing. So the degree, the zeros, every one of these factors will give me a 0. X squared will give me, so if I set x squared equals 0, I get x equals 0. There's a 0. If I take x plus 4, set it equal to 0 right there, I subtract 4 from each side, and I get x equals negative 4. So negative 4. I take x minus 1 cubed. I'm sorry, guys. I'm yawning all over the place here. Set it equal to 0. Well, the exponent really isn't going to matter. So x minus 1 equals 0. Add the 1, and I get x equals 1. Now, this has a multiplicity of 2. Okay? Since it's squared. This x plus 4, that has a multiplicity of 3 since it's x plus 4 cubed. So the 0 of negative 4 will show up 3 times. There's 3 factors that have that as a 0. X minus 1 squared, again, 2. Touch or cross. You can think of that as bouncer cross. If the multiplicity is even, it touches. So that's going to touch. This is going to touch. If the multiplicity is odd, it's going to cross, period. Oh, and then this wants me to use it to graph. So I'm going to graph my zeros at 0, 1, 2, 3, 4, negative 4, and 1 right there. And my end behavior, it's going to go up on the right. So I pick the rightmost 0, which is right there, and I go up from there. Okay? Now check this out. I know, excuse me. Here at 1, it's going to touch it. So it's going to bounce here, and then it's going to come back down to the 0. At 0, it's going to touch it again. So there to there. Try and make it smooth because they don't make sharp turns. And then it's going to cross over here. So cross, and there it goes. And sure enough, my left end goes down to the left. If you get your touching and crossing right up here, all you have to do is start on the right end, and then the left end will take care of itself. Okay, another one. My goal here is to get through this one without yawning once. That's going to be an accomplishment. What's the degree? I've got 2, and there's a 1 and a 1. So 2, 3, 4. Degree is 4. And the leading coefficient is negative, so it's going down to the right. But since it's even degree, they're both the same, so it's going down to the left. Great. My zeros, I've got 4 for this 0. X plus 3, it's going to be negative 3 because negative 3 plus 3 makes 0. And here it's going to be negative 5 because negative 5 plus 5 makes 0. Multiplicity, this isn't going to give me a 0 nor a multiplicity. This, it's squared. See, I didn't even make it through 2 parts of the problem. I had to yawn. It's terrible. Negative 4. 4, right? 4 minus 4 equals 0. Yep. Has a multiplicity of 2, which tells me it's going to touch because 2 is even. Negative 3 has a multiplicity of 1, and 1 is odd, so it's going to cross. Negative 5 plus 5, that's the other 0, has a multiplicity of 1 because the power is 1. It's going to cross. Okay. So I have zeros at 4. 1, 2, 3, 4 right there. -3, 1, 2, 3, and -5, right? Yes. 4, -3, 5. And it's going down to the right. So on my graph, I'm going to go down to the right. As long as I do that, I might just go down to the left. So I just put that end behavior on these. Now, it's going to cross through -3. So I cross through here. I got to come down here. Oh, that's -5. It's going to cross. And it's going to cross at -3. So I'm going to cross, and now it's going to bounce over here. So there it is. And there is my graph. Okay, guys, that is the assignment. It's going to be a quick, I mean, that's the test. It's going to be a fairly quick test. It's going to cover factoring, division, zeros and end behavior, and making equations of graphs. That's really what it is. There's practice test. Good luck, study hard, and I'll see you in class. Bye.